So what I'm here to tell you about tonight, a wind turbine technology breakthrough, an engineering breakthrough that's occurred right here in Western New York. We call it the Newtonian wind turbine. It's a wind turbine that generates far more efficiently than anything that we've ever had before. I feel really frustrated not having my slides here, but we'll do our best to get the message through to you. Our wind turbine is a true turbine. It has 8 blades set inside a cowling, and the cowling is on the outside of the blades, and it rotates with the blades. When we use this, we're accepting 100% of the air mass that enters the face of the turbine. Now, a 3-blade windmill has 3 narrow blades. They occupy about 4% of the span area of the windmill, so that 96% of the energy passes right between the blades and is not used. Then there's a tremendous amount of turbulence created by the principle used to drive it, which is the Bernoulli theorem, which is the principle by which an airplane wing keeps an airplane up, creates a small vacuum above the wing which keeps the airplane up. The same principle is used with a 3-blade windmill. It pulls the blade around, but there's a lot of turbulence. And so as a result of it, if they put a 4th blade in there, the efficiency actually goes down. That's why they're all 3 blades. Now, because of the turbulence, the efficiency of extracting energy from the 4% of the energy they do use is 30% of 4, which is 1.2%. And then it has to go through a gearbox and an alternator, and they lose some more power, so the actual result is less than 1% of the energy that presented to the windmill actually becomes electrical power. Now, the Newtonian wind turbine, which has been developed here in this Western New York area, actually utilizes 100% of the air mass instead of 4%. That gives us a 25% advantage immediately. Also, there's no turbulence. So we're extracting about 50% of the energy. That means that when we go through, we also have some loss in the alternator and mechanisms that attach the turbine to the alternator. We end up, though, with about 40% of the energy in the wind presented to the turbine. 40% is converted to useful electrical power. I'm sorry you can't see a picture of our turbine. We're working on it? Good. maybe eventually we'll get it. You know. What's that?
Can you take this a minute?
Go ahead. She's gonna try.
I'm with you.
Keep going. We'll work on this.
Okay, I'll continue talking. The 3-blade windmills, and you've all seen them out in Lackawanna, I'm sure, the old Bethlehem steel plant. I went out there when they were first installed, and that was quite a few years ago now. I went out there and I was all inspired by the tremendous size of these. But of course, as I looked at them, I was very curious, how are they capturing the energy in the wind? And of course, we learned later that they're not. I saw a seagull fly right directly through those blades, and he didn't know he went through a windmill, and the windmill didn't know he went through there. So what happened was I started a major program to study this whole subject to see if we couldn't do better, and eventually we did. So we built a prototype. A lot of friends helped put this together. Took almost 9 months before we got it constructed. We tested it very thoroughly outdoors, and all the results came out to be exactly what we theoretically expected. Consequently, we wrote a contract with Calspan out in Cheektowaga for one of their wind tunnels, and they ran a full series of tests for us and with us. They had 3 people witness all the tests and all the numbers that were taken, and the results were just the same. Very, very pleasing results as far as I personally was concerned, because a lot of calculation went into this. So the 3-blade windmills out in Lackawanna cost about $5 million a piece. It's a lot of money. And they have 8,000 parts in them. Our little turbines, which produce so much more power, have about 15 components and about 60 total parts and pieces in it. Because they're so much more efficient, they can be 1/8 the size, maybe 1/12 the cost. As a result, you can build a turbine that can be, looks hopeful. You can build a turbine that is very small, compact, and can be nestled into the landscape and be unobtrusive, which is what everybody was hoping for. We've achieved that. The costs of our turbines are, for example, we have 3 sizes. The 3-meter, which is about 10 feet, and it's about the height of the wall behind me. That unit will generate about 10,000 kilowatt hours a year. Now, to have a 3-blade windmill of the same size, it would have to be 80 feet in diameter, 8 stories high, plus another 3 stories to get it up high enough, whereas ours is only 10 feet in diameter. 80 feet versus 10. The next size up is a 4-meter. Oh, by the way, 10,000 kilowatt hours is the amount of power that the average home in the United States requires to provide all their electrical energy. Now, our 4-meter, which is really about 4.2 meters, is 14 feet in diameter. It's a little higher, a little bigger than this wall. It generates 25,000 kilowatt hours. That's enough power to supply all the heat and electricity for the average home. The equivalent 3-blade would be 112 feet in diameter. Our biggest one will be a 8-meter, 25 feet in diameter. It will generate 100,000 kilowatt hours a year, and it would be used for industrial sites. It will also be used for agricultural farms to supply all their electricity and heat. And the equivalent would be 200 feet in diameter for a 3-blade windmill. There's an enormous difference in cost now. Our little one is about a $20,000 deal. The next one is around $30,000, and the last one, $100,000. Now, to give you an idea of return on investment, if that farmer is paying 16 cents a kilowatt hour, with this 8-meter turbine, he would save $16,000 a year. But he can go to the bank and finance this at 100%. And his finance cost would be about $8,000 a year. So with no investment at all, he immediately starts making $8,000 a year. I don't think you can think of any other project, any other product that can do that. It's a very remarkable breakthrough. As a result, we believe that there will be, as this becomes apparent, the efficiency, the low cost, the financeability of this, we believe this will be a major, major event throughout the world, supplying low-cost electrical power and heat, electrical heat, for our industries and our homes all over the world. Now, our company, Kean Wind Turbines Incorporated, is a New York State corporation. We filed our papers about 1.5 years ago, 1 3/4 years ago. We're an American benefit corporation. We will have about 200 shareholders total. These 200 shareholders must come from Western New York. None can own more than 200 shares and not less than 200 shares. They're all equal, 100%. They are the sole owners of the company. Effectively, we are giving this corporation to the community. The corporation belongs to the community. I myself have only 200 shares. We also have preferred shares. And so all shareholders have common shares and preferred shares. The common share gives them 200 votes. I have one advantage here. I have a little special deal where I have controlling votes in case anybody decides to cross me. However, upon my demise, I may be accelerating my demise, but upon my demise, my voting control disappears. It doesn't go anywhere else. And then the remaining shareholders have complete control of the corporation, and it belongs to them 100%. Now, the preferred shares, first of all, common shares people, they also share equally in the dividends from the corporation and its manufacturing operations locally here. That can be quite considerable. We're planning 4 plants, one in Niagara County, one in Erie, one in Genesee, and one in Chautauqua County. Each one will produce about 10 turbines a day, for a total of about 40 turbines altogether. Each plant will employ about 75 people, but all the parts and pieces, which aren't very many, maybe 60 or so, will come from the local community. And altogether, we'll employ about 2,500 people. Now, that's really not a lot, because when you realize the savings in cost of fuel, electricity, and gas for heating your home and providing electricity, this means that everyone in the Western New York area who is on this power will have extra money to spend. And the employment from that will be far greater than the number of people we actually employ. This is a major importance. This is going to happen all over the world. Now, I have some wonderful slides here that I can't show you. We took a good look at the things that are going on in the industry today. And we talk about natural gas at $3.31 per million BTU, as published in the paper today. That's the wellhead cost, by the way. That's not the cost you pay. National Fuel is probably charging you somewhere in the neighborhood of $12 per million BTU, of which you can use, which about, at the best, about 80% of it is usable, and 20% goes up the flue. So the realistic cost per million BTU is around $15 per million BTU. For our wind turbine, our cost is approximately $3 for 1 million BTU. The electrical company will sell you electricity, and it's divided into 2 sections: the cost of the energy itself, which is, and I don't have the slide in front of me, but it's about, here it is. She's got it for me. Here it is. The electricity, it's about $22 for the fuel per million BTU, and about another $23 for the delivery of it, for a total of around $45. That's about 3 times as much as natural gas right now. Our wind turbine, as I said, is about $3, but there's no transportation costs. There's no delivery costs. If the power is used where it's generated. Now, I'm probably going to get in trouble when I talk about solar PV here. Photovoltaic type processes. The numbers I have are without any government subsidies and so on, and we're looking at about $150 per million BTU. However, with the subsidies, they're very competitive with the other sources. Now, the other sources that I just quoted you all have subsidies in them. So if you take those out, they would probably match the amount that solar is without subsidies. So pretty close in there. I'm trying to stay out of trouble here. We're still at $3 though. $3 per million BTU. That's a rather astounding breakthrough in the cost of energy. And because of that, you can actually finance one of these at half the cost of what you can save. Therefore, you can make money immediately with no investment. I can't advance it. I'm trying to advance it. Okay, I've got it now. So upon my demise, the shareholders own the corporation, and they elect the board of directors. The board of directors are also shareholders, and the shareholders, the directors rather, elect the officers of the corporation, and the officers determine the workers in the corporation. And we have now reached the point where we feel that we probably won't need more than 100 shareholders total, but they all must come from Western New York, and they will all be part of this. They will own Western New York. Now, people say to me, who can become a shareholder? Anyone, as long as you live in Western New York, you have the money. The amount of money is $5,000 total. I shouldn't really tell you that, but you're going to ask me anyway, so so that's your total investment, no matter what. Now, we have a great many people who have obtained shares in the corporation because they contributed and volunteered a huge amount of personal effort. Our three principals, including myself here, we've all put in a large amount of personal time. I collect no money from this corporation other than the expenses I run up for the corporation, but I'm not collecting any salary. And two of our other people, both of whom have full-time jobs, have also contributed an enormous amount of energy and time making this corporation go. We started off thinking we needed 1,000 people, 1,000 shareholders. Then I dropped that to 500, then 300, then 200, and now it looks like we're only going to need about 100 because we're just keep going along and plugging along here and getting things done. We do need about 40 more. We've completed 7 of the 8 milestones. We have 1 milestone left, and that's actually building the pre-production prototype ready for starting manufacturing. We expect to be in production by the middle of this summer, as long as we get enough funds in to get us started right away. But even so, we're plugging away. We've got quotations in now for things like the turbine itself, which is one large piece. We have various people quoting on it for the fiberglass construction or for aluminum construction. There's a nacelle that will probably be made in fiberglass. There's a wind vane tail on the wind turbine which keeps it oriented into the wind. And I really feel badly that I can't show you a picture of it, but what's important for all of you to know is that the amount of savings in fossil fuels that this system will provide is just totally amazing. The Marcellus Shale under New York, Pennsylvania, and Virginia has about 80 trillion CCF of natural gas. About only 20% of that is recoverable, however. In the United States, if we provide 25% of the electricity and heating in the United States, we can save the amount of natural gas in the Marcellus Shale in probably 1 or 2 years total. I think that's rather remarkable. All of you should recognize also that we used to get our natural gas from underground in Louisiana under those big swamps down there, and all you have to do is stick a pipe down there, and the natural gas would just flow out seemingly forever. However, they tell me that that's pretty much gone, and that was pretty low-cost gas. And the entire gas industry has been founded on that low-cost gas. Well, now we're turning to fracking. With fracking, you have to drill a hole down 1 mile or more. That's a technology that we didn't have many years ago. It's a very great advance in the ability to drill holes. Go down 1 mile and put a pipe down there. But when we get down to the bottom, you have to turn it right angles, and then they force 10 million gallons of water and sand and chemicals into the shale way down there and break it open a little bit, and then some gas will flow up the pipe. It's a very, very expensive process. We estimate it's at least 12 times more expensive to get gas out by fracking than it is by putting a pipe down in the Louisiana swamps. So we believe the cost of natural gas is going to skyrocket. And one of the reasons it's going to skyrocket is because they still have the price down low. The costs of fracking have not filtered through yet to the consumer, and they probably won't for another year or so. They're encouraging people to build liquefied natural gas plants. One group is building 150 vessels to transport liquefied natural gas over to Europe and Japan. We have groups that are encouraging the closing of coal plants. It's gone down from 47% now to below 30%. These plants are being converted over to use natural gas. We're also switching over trucks in our transportation industry. But I'm being warned, I've got to finish. Anyway, I will shortly, very shortly. So when all of these different uses for natural gas, because the price is so low right now, plus the cost of fracking coming forward, you can surely see that the cost of natural gas is going to skyrocket. It's just going to skyrocket. And so that's why wind power is exactly the way to do this. I have a little sheet, I hope most of you were able to find one, on green energy, or sustainable green energy. This is what we have. These turbines, and this is the end, but these turbines can be placed so that they're connected to the grid, connected to the wind, of course. They also have a battery backup system. So if the grid suddenly went dead, the battery backup system will keep it running even if there's no wind for about 3 days. But if the wind comes up, it'll recharge the batteries and you might be able to go on indefinitely. When the grid power goes off, however, the system is designed so that it instantly develops the power from the battery with not even a flicker of lights. It's all done with alternators. There are no electronic inverters involved whatsoever. And it's a very simple, very inexpensive process. So with that, I encourage all of you to be involved in this community project. If you want to be involved on a voluntary basis, you can earn shares in the corporation. You can eventually own it after I leave this world, which it might not be too long. I'm pretty old already. So hopefully I've given you a little bit of insight, but here I'd like to leave this with you. Any of you here that are interested, we have an office out in Williamsville, 5500 Main Street. There's a big clock on the front of the building. We have an office inside at 102 on the first floor. give us a call and talk to Gail over here. We're in the phone book, I'm sure. Come on over and visit us. We'd be glad to put you to work some way or another. And so thanks very much.